So before we get started, just to introduce ourselves. So here to present the first part is Simon, and my name is Anton, and we're both developers at Kyber. So for those who are new here and are new about Kyber, we're going to do a quick overview of what Kyber is about. And then we'll jump straight into some technical parts where basically you can take off your laptop, and we'll do some small activities together on how you can use Kyber for your hackathon project. Okay.
Okay, so
I guess we can get started.
Okay.
Oh, and at any time, right, anyone can ask questions. So we want this to be as interactive as possible and not so formal. So if you guys have any questions, please feel free to stop us and ask your question.
Yeah. But I don't have the chat open right now. So if you type in the chat, I may not be able to see it.
Yeah, no, I'll monitor it.
Okay, sure. Present. Okay, cool. So for those who are new here, basically what Kyber is a fully on-chain liquidity protocol that aggregates liquidity from multiple sources to allow decentralized token swaps to be enabled to be integrated in any applications. So don't worry if you don't understand any of what I just said. I'll repeat myself at the end again. So this is the problem that we're trying to solve, right? So let me just give you some reference for context. So to date, the UN recognizes about, I think, 180 different fiat currencies. But the last time I checked on Etherscan, there were at least 200,000 ERC20 token contracts. So there's way too many tokens in existence, right? And I guess the first question you might ask is, why is too many problems a token? So to better understand this problem, right? Let me just give you an example, okay? So let's just say that I have a scenario, right? A user wants to buy some Cheeze Wizards NFT with some token, right? So it is not unreasonable for the user to expect to complete this purchase in a single step, right? Like, for example, if you go to a trading card shop, a physical trading card shop, you would pay and get your card in a single step. So in this case, I want to buy this digital collectible and I want to use DAI, right? But in reality, what happens is you actually have to first transfer your DAI onto an exchange to convert into Ether, and then transfer Ether out onto the platform to for example, something like OpenSea to purchase your NFT token, right? So this is problem number one, that the expectation and reality is there's a mismatch between expectation and reality. And actually, there's actually a second problem, right? The second problem is that actually a lot of platforms out there have their own native tokens, right? So in this case, for OpenSea, it's like it's Ether, I guess. But for other platforms like Decentraland, it's Mana token. For Ethereum, it's EMON token. So in reality, the reality can actually be 3 transactions, right? You go from DAI to a base token, ETH, right? And then ETH to the platform's native currency. And then you transfer the token out onto the platform to purchase the digital collectible. So the naive solution, right, is for the dApps to accept every token. Right? This is just good UX for the dApp, but logically it doesn't make sense because the dApps will be exposing themselves to the risks associated with from owning these different tokens and the price volatilities that come along with it. And secondly, if the dApp has its own, the platform has its own native token, right? It doesn't make sense for the platform to accept any other token other than maybe the main ones like ETH, DAI, and maybe their own native currency. So a more ideal solution, right, is to find someone who will be able to buy your token at a reasonable rate and make the trade on your behalf. So that's pretty much what we did, right? So how are we able to solve the 2 problems that we have with decentralized payment flows? At the heart of the matter, what we need to do is to be able to aggregate liquidity from multiple sources into a single pool. And this single pool is like a single interface that the different parties can interact with. So this is like a high-level overview of Kyber's architecture. In Kyber's terminology, the reserve is the equivalent of a liquidity provider, right? So these reserves, they hold like baskets of tokens, and they basically provide rates for the different pairs that they offer. So what happened is that we would aggregate the different reserves, right, into a single interface, which is Kyber network, and the different applications like wallets, dApps, and users can interact with this interface to source for their liquidity needs. So what can be enabled by Kyber? So I think there are like three main areas that really makes sense for a Kyber integration. So the first one would be for swapping service, and wallets are a very good example of this. So these are examples of wallets that have been integrated with Kyber. So just to give you a hypothetical example, right? So let's say I am using a wallet that is integrated with Kyber, and I want to buy coffee, right? I go to this cafe accepts cryptocurrencies. So what happened is that, unfortunately for me, I don't own the token that the cafe accepts. But the good thing is that because I'm using a wallet that is powered by Kyber, that is not a problem, because I can still pay in whatever token I want, and the vendor, in this case the cafe, can still receive in the token of their choice, right? Additionally, some of these wallets offer, right, is something we call embedded token swaps. So what that means is that the users can swap from one token to another token natively within the wallet, without having to transfer the funds out of the wallet. So this is like an additional service that's provided by the wallet, and it's good for your users, right? Because it allows your users to basically react quicker to like sudden market events. Like if, for example, the market crashes, you don't have to transfer your funds from the wallet onto an exchange and wait for like 30 confirmations or something like that, right? So sorry. The next example would be you could even build like exchanges on top of Kyber, right? So this Kyber Swap is our own in-house swapping service. It's a decentralized exchange that has been built entirely using the on-chain liquidity protocol. So the next group or the next use case would be for payments. So so events like AdCon or like e-commerce site like Hodl Moon, because of the integration with Kyber, what they allow their users to do is to pay in any token, but yet they are still able to receive in a token of their choice. So from the end user's point of view, it's still one transaction. They pay in whatever token, but in the back end, what we do is we help them to get the best rate for that token from all the different liquidity providers that have been connected to Kyber. We do the swap on their behalf, and then we pay the different vendors again on their behalf as well. And the last big use case, I guess, is for financial dApps, right? So financial dApps like Melonpot and Fulcrum, they allow you to do like instant portfolio rebalancing and margin trading, lending, all natively within the application, so the users don't have to leave the applications to do this kind of advanced financial instruments, I guess. Yeah. So in short, based on the examples that I told you earlier, right, the benefits of integrating Kyber would be like you basically provide better user experience for your dApps, and in some situation you might even be providing more services like the in-wallet swaps that I talked to you about. And because we are fully on-chain and non-custodial, you get the benefits of being fully on-chain and non-custodial. And that because we also aggregate liquidity from multiple sources, we can guarantee that you always get the best rate available at the point of a token, at the point where you execute the token conversion. So these are just more examples of what can be powered by Kyber, right? So you have vendors, dApps, wallets, exchanges, decentralized finance, and token teams. Is it not moving? Yep. And yeah, so this is our like all the integrations all the projects that have integrated Kyber so far, right? So based on the sheer quantity of projects that have integrated Kyber, it just tells you like it's super easy to integrate Kyber, and it really, I mean, it makes sense. There's a lot of benefits for integrating Kyber. Yeah. So in summary, to solve the two problems that come with decentralized payment flows, where the user's expectation does not match the user's reality, and that there's just way too many. It's just not feasible to own every every native token for every platform that I want to use, right? What we created is a fully on-chain liquidity protocol that aggregates liquidity to power token swaps in any applications. Yep, so that's the end of the first part of the presentation. So if you want to join our community, we have 2 Telegram channels if you have any questions to ask. This is the developer portal where you can get like integration guides, you can get the different APIs and ABIs, and this is our workshop repo if you need help. Like if you want to test locally, you can use the workshop repo. Anton will be going through the different ways of integrating Kyber next.
Yep. So yeah, before we dive into the actual technical parts, right? I just want to head back into this what we call the ecosystem map. Just one moment, over here. So based on what Simon presented, right? Hopefully it gives you an idea of like what you can do with your projects, and if you need any kind of like examples of you know, what you can use with Kyber, then you can just visit to any of these projects just to give you an idea, right, of what you can actually hack using the Kyber protocol. And of course, like in the presentation as well, Simon mentioned that you can visit our Telegram, so you can always ask questions directly to us in there as well. So moving further along, I'm going to get into the technical part of the workshop. And for this, I'm going to be sharing my screen, so give me a few moments. Maybe you can unshare your screen.
Yep. I have to figure out how to do that.
Yeah, you need to stop sharing.
I don't know where is it. Stop sharing.
Yeah, there you go. All right. Okay. Oops. Okay.
Do you want me to mute here?
It's okay. Yeah. So again, if anyone has any questions, please feel free to interrupt and just ask your question away. Before we get started to the repo, I'm just going to show you our developer portal and how you can actually find information. I hope it's quite clear. If not, you can just visit the developer portal yourself. So it's at developer.kyber.network. The first page is basically just the high-level overview of what Kyber does, and Simon has pretty much done a good job on covering that. But if you need more details or you need to review this information, you can always visit this page. The more interesting part that you need to look at is the integrations section over here. You can find it on the upper part, the header. And so in the integrations, right, there are actually multiple ways on how you can integrate the Kyber protocol. There's the native way where you directly talk with our smart contracts. There's using our RESTful API. And also there's a simple way of just integrating a widget, right? And I'll cover this one by one. So depending on your use case, right? So we gave some example use cases, like if you're a DApp or if you're a vendor or a wallet. We gave some use cases as well of like how Kyber helps your DApp or your wallet and how you can integrate it, right? And so again, here are the different types of integration, like using the smart contract. And basically in this guide, right, we teach you how to talk to our smart contracts directly. So for example, you've written your own smart contracts and you want to do like a trade, right, a token swap. In this guide, you can actually, we give it to you step by step on how you can talk to our smart contracts, like get rates, conversion rates, and being able to call the trade function to be able to execute this trade. So there's a long guide over here, such as how to deal with allowances, ETH to token, token to token, token to ETH, and other cases. We also have a guide on how you can do this through Web3, like if you're written a DApp and you need to communicate to the Kyber smart contracts through Web3. We have here a full guide as well, such as how to do, again, through Ether to token, token to ETH, and token to token. And last part is we have an API for those of you who would just like to, or who don't need to directly talk to a smart contract. We have an API that we provide that where you can, for example, query conversion rates, the tokens that are supported in Kyber, and other information. And we'll actually get into this API in a bit. And the most simple type of integration that you can actually do is what we call our widget, or the Kyber widget. And essentially what it basically is that it's basically just a type of widget that covers like for you to accept easy payments, right? Or this decentralized payment flows, right? In your website. So if you're, for example, a vendor that's selling an NFT, right? And you want to receive like any token, you can actually just integrate this widget, and it will help in your workflow of being able to accept different tokens. And just to show an example of how it looks like, you can visit this Kyber widget generator. And in here, you have several parameters where you can input, like, for example, the recipient address, which is your address. What type of, let's say if it's a payment type of use case, right? Then you can specify like what type of token that you want to receive. So let's just say I just want to receive like USDC or any other type of stable coin like DAI, let's say. And then other parameters like the callback URL for your backend, so to notify your backend that a payment has been processed. And how it basically looks like is that if you click the preview button over here, this is what the widget generated would look like in your website. And so let's just say that you specify a certain amount that you want to receive for your good, let's say like 10 DAI over here. And if you generate the preview over here, that it will say like, okay, there's 10 DAI over here and you need to pay 0.016 ETH. If you switch it to another token like Omisego, by the way, this isn't Ropsten, so we don't have much tokens over here, but if you switch to mainnet, then you would see the full list. So yeah, basically conversion is automatically done on the UI side, or shows it to the user as it reflects to the actual amount that you as the receiver want to receive. We also have different modes like swapping. And this is basically like you would expect in like a DEX, right, where you swap from one token to another. Like I want to swap, let's say, KNC to, let's say, DAI, and I want to enter like a 10 KNC. It will show me how much DAI would be receiving. And just to show you how it works, right, first is the input of how much quantity you would want. And the next stage is unlocking your wallet, so you can connect your MetaMask, your Ledger, Trezor, Keystore, private key. So we provide multiple options as well. And afterwards, after connecting like your MetaMask, you just confirm the transaction and it broadcasts it into the blockchain. So yeah, so this is basically the widget, right? And just to show you how it looks like in action, right? By the way, it's basically as simple as pasting an HTML code. So after like inputting some basic parameters over here, you can just copy this code over to your UI, to your web page, and you basically have the widget integrated in your dApp already. So it's as simple as that. And just to show you how it looks like in action, right? We have here CoinGecko, which is one of the integrations that we've done. And so, for example, if we could look at like status, right? Over here, so this is only supported to ERC20 tokens right now. And they've put this buy, sell button over here underneath the price. So if you click this, it actually shows the widget that they've integrated, and it shows the conversion like from, let's say, ETH to SNT. But you can choose, of course, any token. Let's say I want to choose, let's say, mana, right? And if I have 10 mana, then it shows me how much equivalent in NST I would be receiving over here. And again, I just go through the flows where I unlock my wallet, and then I confirm the transaction. And if your wallet hasn't done the allowances yet, then the widget automatically handles this for you as well. So it asks for the user to provide allowance and then executes the swap. So the widget, again, is one of the simplest ways for you to integrate the Kyber protocol in your dApp. So aside from the widget, you can do a native integration, right, or through Web3 as well. And I can show you a brief example of how this is done. So we have InstaDApp over here, and they're actually one of the most popular DeFi projects out there. And they've integrated Kyber as well, but they've done it natively through smart contracts. So on the right-hand side, you can actually see here the different balances of the different tokens, of your own tokens, and you can actually buy them. So just an example, right? I want to buy some DAI, or let's say I want to buy some PNC, right? Over here. When I click this, it shows me this custom UI, right? So they basically built a UI around the smart contracts, right? And underneath, right, they just directly call our smart contracts to execute the trade. So here I just like enter like a quantity over here, and it shows like how much DAI, how much USDC I need to be paying to buy KNC. And of course, I don't have enough USD. I think they only accept USDC for in this case. But I've done a sample trade. So if you go to this Etherscan transaction here, you can actually see from their contract, they are actually calling the Kyber network contract, which is this one. And I just bought basically 1 KNC over here, or sold 1 KNC in this case, yeah. So that's just an example of like what you can do if you integrate locally, natively with the smart contract to the Kyber, with the Kyber protocol. So you can build like a UI, custom UI around it. Yeah, and the last part is the RESTful API. Let me just show you briefly. So we have an additional section over here called API ABI. And here we detail the other parts of like the actual information that you might need for like interacting with our smart contracts and the API as well. So for the smart contracts, let me just open this over here. You probably might just need the interface, which is like the main contract that you would want to interact with. So for example, we have the functions like getting conversion rates, which is this get expected rate, and then the actual trade function. So actually, when you interact with the Kyber network protocol, you only need 2 functions to be able to interact with it. The first is just being able to get the conversion rate of one source token to the destination token, or let's say from each token. And then afterwards, you pass this information to the trade function over here. And that's it. It will execute your trade. And we'll go through this step by step as well when we go through the actual code. Now for the API itself, we have here some API endpoints that you can use. So for example, from the API, you can get information about, let's say, currencies, right? Over here, let me just pull like an example over here, overview. Here are the main endpoints for the different like testnets and the mainnet as well. So for example, if I call like /currencies over here, which is one of the endpoints, then it will show you all the different tokens that is supported in Kyber. And it will also return different information like the token address, the decimals, the reserves that are supporting this token, etc. So we have different endpoints as well. For example, one interesting endpoint is, for example, the buy rate. Okay, maybe not that one. Maybe a simpler examples like market. So this is the type of information being returned. Let me just show you how it looks like. Again here, so from the API, you can again get this information like decimals, address, etc. You can get the volume and then the conversion rates as well, like for the different tokens. Let's say like ETH to Omisigo, here you have like the volume and then the current bid and ask. So again, by using the API, you can build like really unique applications on top of this without having to directly talk to our smart contracts. So I guess those are the 3 main things on how you can integrate the Kyber protocol. And now let me share you like how you can actually play with it locally in your machine. We have a repository called Workshop. So you can go to github.com/kybernetwork/workshop. And this is the workshop over here. We have the full guide over here as well on how you can test this locally in your machine. So you basically just have to clone it. You need to have the truffle ganache installed as well. We have a brief introduction of like what is the different files and the directory structure in the repository as well. We go through each step on how you can run them, and we have some example smart contracts, scripts, etc. in that workshop. And so let me get to running this to show you how I can actually run the Kyber smart contracts locally in your local machine, right? So let me pull out my terminal over here, and I hope everyone can see it. Let me just zoom in a bit. And so, like in the tutorial, right, here in the guide, I can actually, let me just run the ganache locally. So I'm gonna start from scratch, right? We actually have a snapshot, a ganache snapshot, which with all the smart contracts deployed, so you don't have to do a truffle migrate anymore. But if you want to start from scratch, then I would recommend like running this over here. Of course, please do not use this mnemonic over here in production. This is just meant to be used as an example, so that we can always expect the same addresses to be used, right, when we're deploying it. So let me deploy it. Let me just start it with more ETH, like 10,000 ETH over here. Okay, now it's running. And on another terminal over here, so let me just clear this. I'm going to do a truffle migrate. Okay, there. So in our repository as well, we define many other networks. So we have like the mainnet, we have Ropsten, Coven, etc. So you can actually do a truffle migrate to those different testnets as well. But of course, in this demonstration, we're going to do it to our local Ganache instance. And you can just check out the truffle config to see all this, definitions. So let me just execute this, just to show you like how it looks like. Let me zoom in a bit. And so we have the complete list of different Kyber smart contracts in this repository. You can see as well as the migration is going on, the different configurations that's being done. So we're actually deploying some mock tokens as well, like Mana, Misigo, the KNC token, Zilliqa, etc. And we're setting up many different reserves. So in Kyber's context, right, if you're not aware how liquidity is provided in our smart contract is that we have different liquidity providers, which we call reserves. And these reserves are basically just smart contracts. So here we're deploying the different tokens and then deploying the contracts in a bit. Yeah. So there's definitely a bunch of contracts. And of course, feel free to modify any of these contracts to fit your project. Yeah. Here we're doing some basic setup of the Kyber network smart contracts, setting up the different reserves. Setting up the initial conversion rates of the different tokens. And we're almost done. And so if you're curious of how Kyber network works, right, you can actually just study this migration scripts and the contracts as well, just to see like how it works underneath. And just like in the repo, right, in the documentation, we have the same address generated as well. So we have here the different actors in the contracts, like we have an admin, operator, alerter. You don't have to worry about this for now. We have our own user address over here. We have the different mock tokens deployed. And we have the different Kyber smart contracts deployed as well, like the different reserves. Of course, the great thing about Truffle is that it shows you how much you spent to deploying these contracts. Now we want to actually test out that we've deployed these contracts correctly, right? And if we get back to the repo, we can actually run some examples over here. So there's this folder called examples. And we have 3 examples. We have a Solidity example. So these are actual smart contracts that is interacting with the Kyber protocol. We have some Truffle scripts. So basically in Truffle, right, Truffle is just like using Web3, but then some of these artifacts, like for example, like contract address and definitions are automatically exposed in Truffle within the Truffle framework. So Truffle scripts basically makes doing like simple scripts easier, right? But of course, we also have some regular Web3 scripts to execute this examples, right? So let me just get to my IDE over here. And here I have the workshop. I hope everyone can see this if it's not too zoomed out. Here, let me just show you like some example Truffle scripts for now. Okay, over here. So let me first run this script. So basically what the script does is that it gets the different conversion rates of the different tokens that is deployed in our Ganache instance. And we've deployed like several test tokens. Let me just run it. So let me do like truffle, exec, examples, truffle, and get expected rate. Let me just run this. And again, this is communicating with our local Ganache instance. And so you see here, of course, this is returned in token way. We see the conversion rate, let's say from ETH to KNC. We have the expected rate and the slippage rate. We have like a ETH to Omisigo, ETH to Mana, Mana to KNC, let's say. Yeah, so these are the different conversion rates. And basically how it works is that, so how reserves serve this liquidity is that they hold inventory of the different tokens and then they set prices themselves. Of course, it's more complicated than that because we have different reserve types. And we've also integrated with many different reserves, right? So like in mainnet, we've actually integrated as well with Uniswap, with DotchX, with the Oasis DEX, etc. So we pull additional liquidity from those different liquidity providers as well, not just from the normal reserves that you see in Kyber. And we always use ETH as a base pair, so going from token to token is always possible. So it's as simple as this for getting conversion rates. And you can always think as of Kyber smart contracts as an on-chain oracle, in a sense, right? You can actually use the Kyber smart contracts to be able to pull prices on-chain because all our operations and data is on-chain for Kyber. And just to show you how it's actually done, let's go through the truffle script together. By the way, this over here, the 0xEE, because ETH itself is not a token, but we need some way for, to represent ETH in our smart contracts. You can just think of this as an alias. And you can actually find all of this token addresses as well in our developer portal. So if you go back to our developer portal and you go to environments over here, you can find the different contract addresses of the different testnets and mainnet as well. So we have the full list over here for your reference. And so let's just go through the code line by line. So here we are just doing a simple call to the network proxy, which is the main contract that we would want to interact with when we're interacting with the Kyber protocol. And we're calling the getExpectedRate function. And we just pass in 3 arguments. First is the source address. So I'm going from, let's say, ETH, and then the destination address, which is the KNC token, and the quantity of how much ETH source quantity I want to trade for KNC. And it's the same thing for any other, like let's say if you go from token to token, I just need to call the same function and just specify the source address and then the destination token address and how much quantity again. So it's as simple as that. It's just 3 arguments and you're able to get the conversion rates. And let me explain the 2 different return values that's returned. So we have the expected rate and the slippage rate. So the expected rate is the exact conversion rate between the source token to the destination token. But the slippage rate is basically like a, you can call it like a buffer, right? It's basically 3% more of the expected rate, which is kind of like hard-coded in our smart contracts. And I'll explain more of like why we provide this rate later on when you call the trade function. Yeah, so these are the different information that's being returned. Now we want to do an actual trade. So let me show you a script, an example script that does an actual trade. So let me execute it first over here. And the function is called trade. So first I show the initial balance of the user's address over here. He has about 10,000 Ether and about 1 million of KNC and other tokens. And I've done 3 trades. So I did an ETH to KNC trade, a KNC to Omisigo, and so forth and so on. And so because I've done an ETH to KNC trade, I have lesser ETH right now and more KNC. And it's the same for the other token pairs as well. So because I did the trade from KNC to Omisigo, I have more Omisigo balance as well. And you can actually execute this again to see how it's run again. There we go. So again, like the previous one, we have the, this is initial balance. We do 3 trades, and again, our balances are updated. It's as simple as that. Now, to show you how much more simpler it is to actually call this trade function. So again, simple declarations over here. We set the instances of the different tokens. We show our initial balances of the user's wallet, so the ETH balance, KNC balance, etc. First, we need to call the get expected rate to get the conversion rate between the two tokens, or let's say from ETH to token that I want to trade with. So let's say I just want to trade 1 ETH, right? So I get the conversion rate between ETH to KNC, and I get this 2 return values, right? And from this 2 return values, I can use the expected rate or the slippage rate as an input to the trade function over here. And the trade function has a few parameters that's needed. So for example, I need to specify like the source token, the source amount, again, the destination token, the destination address, which is my own wallet. And this is where the flexibility comes in. So for example, I can specify any destination address. I can actually specify another smart contract where further execution will be done as a cascading like operation, right? And then the max destination amount of like the destination that's the max destination, or the maximum that the destination is receiving. And if, for example, the amount traded is more than the destination amount that you specified, the user will actually receive change in return. And then the conversion rate. So this min conversion rate means that this is the minimum acceptable rate that you would want the trade function to use to execute your trade. And what it basically means is that because with the properties of the blockchain, right, when your transaction is in flight, rates could change. And so you would want to give some kind of like a buffer, right, in case in the event that rates change. And so we provide the slippage rate over here, such that in case the price falls by 3%, then we can still ensure that the trade executes because we have a buffer of 3%. But again, you can actually input any number over here. So you can, for example, get input here like 10% of the actual rate or the actual expected rate over here, which means that you can the trade can tolerate up to 10% difference from the actual rate that's being used when the trade executes. So there's no exact like quantity that you would be receiving right when the trade executes. You can actually be receiving more of the tokens because trades were more favorable in your case when the trade executed. Yeah, so it's the same way for the other like token to token trades. Like here I have a KNC to Omisigo over here. Of course, one warning, right, that you need to take note of is that when you do token to token trades, you need to always provide allowance first to either your own contract that's calling the Kyber smart contracts, or you need to provide allowance to the network proxy contract, which is the main entry point of the Kyber smart contracts. So before I actually done this, you can see here I've called approve to the KNC token over here because I'm trying to trade from KNC to Omisigo. And afterwards, I've just done a get expected rate to get the conversion rate, and then I've done a trade. So it's as simple as that. So it's actually just 2 functions to be able to interact with the Kyber smart contracts. And I can show you an example using Web3. Of course, it's not that different from Truffle. It's just more declarations, but I can show you that as an example. So we can go over here, and we can run, for example, get expected rate to get the different rates again, and we can run trade over here. Right. And if we open the example scripts over here, like let's just go straight to trade. Here, just like in any Web3 script, I just declare my instances and addresses and the ADI, etc. But the more interesting part is like here I'm broadcasting my transaction. But the more interesting part is how I actually interact with the smart contract. So from my network instance or the proxy instance, I again just call get expected rate, passing in the needed arguments, and then I call trade over here. And that's it. You've actually done an actual trade in using Kyber. It's as simple as that. We also have different functions to help you out to make trading much easier. The trade function is actually our most flexible because you can specify more arguments here. But we actually have a simpler function that you can use. we have, for example, the ETH to token function, swap Ether to token, swap token to Ether, and swap token to token. And just to show you what it looks like. Again, I need to call it get expected rate. And here we have the swap Ether to token function, and I just specify again just the destination address and then the conversion rate or the expected rate. So just 2 arguments. And how it works is that this swap Ether to token is just a wrapper on top of our trade function, and it just provides the trade function with all the other arguments that's needed. For example, the destination address is already the message.sender or the user's wallet that's calling this function, and so on and so forth. So if you want something as simple as just doing a simple trade, then you can just call this function. But if you want more flexibility, you would definitely need to use the trade function. And we have here some Solidity examples as well. So if you want to, for example, embed token swaps into your own smart contract, you can do so quite easily. And just to show you an example, I actually wrote 2 functions over here. So my first function over here is swapping from ETH to token. And I'm taking as an input, right, the destination token, the destination address, and max destination amount. And from here, right, I'm just interacting with the Kyber smart contract. So in construction of the smart contract, I inputted the network proxy address over here. So this is actually calling the network proxy Kyber network contract. Again, it's just 2 functions. I'm just calling the get expected rate to get the conversion rate, and then I'm calling the trade function, passing in the ETH value that I want to trade and the other arguments over here. It's as simple as that in your smart contract. And again, it's the same thing for like a token to token swap. And so I'm getting the token addresses like the source token, the destination token, etc. Of course, because I'm dealing with tokens, I need to do a transfer from, and then I need to be able to transfer these tokens into the Kyber proxy contract. So I do this simple lines over here. And it's as simple as, again, as calling 2 functions, which is the get expected rate and trade functions over here. And you can actually imagine being able to do multiple trades within 1 function call. So I have here my exec swap over here, right? And I can actually duplicate this, right? So within my 1 function call, I'm actually doing two trades. So for example, I can have 2 different source tokens, like source token 1, source token 2, and I'm trading those to the same destination token, or I can even change it to a different destination token. So you can imagine like being able to do multiple trades in 1 function call. And this is actually what some DeFi projects have done. So when they do rebalancing on chain, right, they're actually able to rebalance multiple tokens in 1 function call. Of course, there are like gas considerations over there, but just to show you like the simplicity of being able to do all these complex processes in a single transaction. Yeah, so that's that in a nutshell. We have all these examples are over in the repo, and you can just play around with it. If you want to play around with the Kyber smart contracts as well, feel free to do so, and just playing around with the repo. And so going back into the idea, right, of the Cheeze Wizards hackathon, right, like what Simon presented over here in his presentation, you're actually able to, like a simple use case, right, is a payments use case where you have a marketplace that you're selling these different Cheeze Wizard NFTs, and you want to be able to let your users to accept like different tokens. And you can do that in 1 transaction, and it all occurs on chain. So taking again the advantages of using a blockchain, which is transparency, decentralization, etc. But you don't need to stop right there, or just stop there. There's this blog post posted by the Dapper Labs team on what you can build with Cheeze Wizards, and they actually gave here some really cool examples, like a dating simulator over here, and exchanges, stat scanners, etc., or a wizard exchange, right? And so you can actually imagine being able to integrate Kyber and all these different ideas, right? So for example, you can have like an auction, right, for this different Cheeze Wizards, and this auction doesn't need to just accept ETH. You can actually accept many different tokens. you can have like a league, right, or a pool, like a prize pool, right, where it's actually accepting many different tokens, but this prize pool is just in, let's say, a stable coin like in USDC or DAI. And so you can actually create that. And again, the best part is that this integration just needs two functions, and all these operations happen in a single transaction. So that's kind of like the main benefit of being able to do all these. Yeah, and the best part is that you know, the great thing about all these protocols is that of composability. So, for example, you can have your let's say your dApp, right, integrated in other projects like maybe in InstaDApp or CoinGecko or MyEther wallet, let's say, right. So, like in MyEther wallet, just to show another example, and what Simon mentioned earlier, you can actually like trade Kyber within the app, right, natively within the app without having to leave it. So. Yeah, so for example, I would want to like swap, let's say, ETH KNC over here. It's doing it through Kyber as one of the options, and it's doing it natively within the MyEther wallet dApp over here. And so you can just imagine being able to do this in your own dApp with Cheeze wizards, yeah, in whatever you plan to make of your project. But of course, if you want to go through the simpler route, you can always use our widget over here, which we presented earlier over here. Simple as that. Yeah, so I guess that's like the bulk of the presentation. If anyone has questions, please feel free to ask. I guess that we can have this time to have a Q&A, simple Q&A. And I hope like everything is clear. So if you need the links to any of this information, so the simpler one is that you can just go to our developer portal, which is developer.kyber.network. And from here, you can actually find links to our developer Telegram if you need any help, to reach out to us directly. And then we always have our repositories, so you can go to the Kyber Network main GitHub channel, I guess, and then go to our workshop repository and see the many different examples from there. Yeah, so it's basically as simple as that. And if you need a link to the slides, I guess we can provide that as well. Yeah, so I hope you guys can, hopefully you can use Kyber in some way in your project. If you have any questions, please feel free to ask. We have the floor open now for, I guess, a brief Q&A before we wrap up. If anyone has questions, feel free to enter them in the chat or voice them out. Desmond and I will be happy to answer your questions. Oh, sorry, Simon. Yeah. I think there's going to be a recording as well of this workshop. So for those of you who would want to review this, you can always check out the video or, yeah.
Awesome. Thanks, Simon and Anton. That was super helpful. We will definitely have a recording of the workshop. We'll also send it to everyone who's registered for this workshop, so that they can, if they don't have any questions right now, they can just obviously review the recording of the workshop and then get back to you with questions. Apart from that, I also wanted to highlight the Kyber bounty for the 0x for the Cheeze Wizards Hackathon. So I'm just going to put this document in the chat, which contains all of the information that regarding the bounty, which is something that we really hope that you would participate in, given the amazing stuff that Kyber is working on. And yeah, if you have any questions, feel free to jump in. The team is always available. They're also available on Discord as well. So if you have any questions, I'm happy to relay it to the team as well.
Yes, definitely. Yes, so please check out our bounties. We have some very attractive prizes, and we're really looking forward to all the projects that you'd be building. So yeah, so happy building, and please feel free to ask any questions again through Discord or Telegram or any medium, right? We're always reachable, right? So not just me and Simon, but we have other devs in Kyber as well that can help you out. If you need any clarification with any of the we presented here in this online workshop. Yeah, so I guess if any questions from anyone? before we like wrap up? Do you have a question, Simon? Just kidding.
No, I don't have a question. Do you have a question, Anton?
No. Yeah. Yeah. Hopefully, no questions mean like it was very clear. So yeah. So feel free to always reach out to us. And thank you again for the Cheeze Wizards team, to the Dapper Labs team, right, for giving us this opportunity to conduct this workshop with everyone.
Yes. Thank you very much.
Awesome.
Yes.
Thanks, guys.
All right. Thank you so much.
Bye.
Bye-bye.